Okay, so this lesson is going to be on quadratics and how to do transformations and change it around and move our graph. So I'm going to do this in Paint. Jason, can you see this?
I can see it.
Yay. Okay, so here's the thing that we want to look at. First of all, what is a quadratic equation? And a quadratic equation is sometimes called a function, a quadratic function. It just means your variable is squared. So if you have a quadratic, anytime we're using that word quadratic, either function, equation, we're thinking that the variable is squared. Okay, so let me give you some examples. Oops, squared. So you might see the formulas in the form y equals, maybe this is called vertex form, in the form x minus h in a parenthesis squared plus k. So this is vertex form. Or you might see it with the f of x instead of the y with the same thing. That's function form for vertex. So we could exchange and have an f of x instead of a y. So just know that these are actually the same thing. So if you get confused by that function form, which is the f of x, you can actually convert it back to the y and then do your problems with the y instead of the f of x. Another way that we could write a quadratic, again, I could use y or I could use f of x, is in standard form, which would be ax squared plus bx plus c. And this is standard. Some textbooks might call it a different thing than standard form, but most go with standard and then vertex as your two forms. So we call this one up here vertex form because you can see the vertex. And when we're talking about the transformations that we're going to discuss today, most of our equations will be in this form for us. When they're in this form, we can't follow the transformations, and so it's really hard to do the transformation. So let's look at a parent function for this. So a parent function is like, what is the general function look like? What does the graph look like? That's our parent function. And then whatever we do to that parent function is our transformation. Okay, so here's the parent function for a quadratic. When I write, it does kind of look like a second grader, but it's hard to write with your mouse. So the parent function looks like f of x, and again, you could write that with a y, equals just x squared. So you could see it as y equals x squared. This is our parent function. So let's think about the graph and what this would look like. Anytime you're looking at it to graph something, you could make a chart and graph it that way, which is what we have to use anytime it's in standard form. Okay, so if I want to use a chart, I could think of it as x and y, and we have to think, okay, so what numbers will I put in for x and get out and graph from there? So I always start with 0. So I'm going to put in 0 into our function, and remember y is the same as f of x, so this is like f of x. So I'm putting things in for x, and I will get out f of x or y. So if I put in 0, I go over here, 0 squared is going to be 0, so I'm going to get out 0. So input, output, or domain and range as well is another way to think of these. So if I put in the number 1, go up here, 1 squared is going to get me out 1. If I think about the negative of 1, negative 1 squared will also get me out 1. I'm out of room, so I'll have to continue over here. Okay, so continuing on the same thought, what if we put in 2? Well, 2 squared is going to get us 4. What if I put in negative 2? Negative 2 squared also gives us 4. Now be careful how you put in the negative 2 into your calculator. If you use your calculator, maybe it's a higher number or decimal. Make sure that you put a parenthesis when you square something in your calculator, or you'll get a negative answer. So just remember, every time you square something, you better get a positive answer. Okay? All right, so then let's graph this and look at what the general graph is going to look like. Okay, so you're going to have to bear with my very not so precise graph. Okay, so let's graph the first point is 0, 0. Okay, our second point would be 1, 1. So if I go over 1 on my x, up 1 on my y, that's going to be here. Okay, and then negative 1, 1, I go over 1, negative 1, and then up 1. There's the point negative 1, 1. And then I'm going to go over 2, up 4. 1, 2, 3, 4. And then negative 2 is also up here 4. So this is my parent function. If I drew this, it looks like a U, and it's called a parabola. So the ugly name parabola there. So that's our parent function. That's what it looks like. So you can always go back to this function when we're doing transformations and what am I doing to this function. So I'm going to move to a different screen. I don't know. Oops, I want to do a new one, but maybe I'll save this one. Okay, so from here, because I might want to go back and show you that parent function again, or I'll draw it again either way, but let's look at what the numbers, if I put in numbers, what are they going to do to this function and what are they going to change it and make it look like? So that's what transformations are. They are going to move that graph around. So let's look at the main formula for it, and I'm going to use the f of x in there or the y, either way. The main formula says you have a times x minus h squared plus k. So a, h, and k, you're going to have numbers in those places, and they're going to do different things to your graph. So let's start with a. What does a do? Well, if I have a negative number there, it is actually going to flip my graph over and make it an upside down U. So it goes upside down. So let's write that down. So if A is negative, it will reflect the graph over the x-axis or flip it. However, that helps you remember that. It flips the U upside down. So is negative, the way we actually say that is reflects graph over x-axis. So that's like what you'll see in your textbook. It'll say it reflects it, and you just need to remember it flips it upside down. Okay, so if it's negative a, it flips it. What if a is a number? Well, if a is a bigger number, like larger than 1, like maybe it's a 2, a 4, a 5, a 6, going up to 100, whatever the number is. Or if we think of it as a negative 2, negative 3, negative 4, anytime that number is larger than 1, or the absolute value is larger than 1, because the negative just flips it upside down, it's actually going to take and make a vertical stretch or make it skinnier graph. So we're going to write this down. I'm going to show you an example of it too. So if the absolute value of A, meaning it could be negative or positive, is greater than 1. So if A is just 1, we're at the same shape as the parent function. Anytime it's greater than 1, so 2, negative 2, 3, 4, 5, that's when we're going to do a vertical stretch. And so vertical stretch, it makes it look skinnier, is the fancy word. My fancy word is skinny, all right? And then the next thought would be if it's less than, so if this number A is less than 1, so that's going to get us fractions, decimals, fractions. So if A is smaller than 1, it's going to be a vertical compression. Vertical compression. And this should kind of be familiar from doing this with the linears. So my idea is this makes it fat, except it's different when the shape changes on you a little bit. But Okay, so one makes it skinny, one makes it fat. So if you have big numbers, it's going to make it skinny looking graph, and if it's got a smaller numbers, it's going to make it fat. So let's look at some examples of what I mean by skinny and fat, and then we'll look at the H and K numbers in just a second. Okay, so here's an example. What if my graph is f of x equals, let's do 2x squared. Okay, if we go up here, it's like saying I put a 0 in for h and a 0 in for k. All I have is an a and an x squared portion. So it's still in vertex form, but it's a little confusing when we start looking at standard form because it's really in both. But what does the 2 do to this graph? Well, let's look. We know we can use a chart to graph this, so that's what I'm going to do just to show you the difference. So I'm going to do a little chart. And one way that I kind of like doing the charts is my work in the middle. So this would be the formula 2x squared. And this might just help you with keeping your work in the same place. But so if I put in the number 0, so I would have 2 times 0 squared. Well, we know 0 squared 0. 0 times 2 is 0. Right? So there's my answer of 0, 0. Then from here I could put in a 1. So 2 times 1 squared. 1 squared is 1. 1 times 2 is 2. Okay, so before when I put in 1, I got out 1. So you can see that that number is larger. Okay, so it's vertically stretching it out or jumping up faster. Let's put in -1. -1 squared. Again, think of this as a parenthesis so that you're squaring the -1 gives you +1 times your 2 is a 2. So you get out the same answer. I ran out of room again. So let's do, I always call it y, but you could put it in as f of x too, here. Okay, so then what if I want to try the number 2? So if I put in 2, it's like 2 times 2 squared. Well, 2 squared is 4. 4 times 2 is 8. So that number is a lot larger than we got last time we did this too. So now let's put in -2, and we better get the same answer, and you better start seeing a pattern for why I do positive, negative, because it really shapes your U for you. So -2 squared is 4. 4 times 2 again is another 8. So let's look at this graph. All right, so we know we have 0, 0. Okay, and then 1, 2. 1, 2 would be here. -1, 2 is here. And then 2, 8. Okay, 1, 2, 3, 4, 5, 6. I didn't make this long enough. 7, 8 would be here. And -2, 8. Oops, now my mouse won't move. -2, 8 is about here. Okay, so here's my U shape. And if I think about the parent function would have been through here. 1, 1, 2, 1, 2, 3, 4. Okay, so here's the parent function. I'll do it in a dotted. Okay, so we can kind of see. Do you see what I mean by skinny? So the dots are what the original graph parent function would look like. And when I put that 2 in, it made it skinnier here. Now, if that number gets even larger, what if I would have used a 5 here, which I didn't because the numbers get so big it's hard to graph. Then the numbers get really big really fast because you're timesing them by a factor of 5, and then it would be even skinnier here. Okay, so that's kind of what the 2 does, and it's the same idea when I have 1/2 instead of a 2 or 1/3 or 1/4 or any fraction. It makes it fatter. It would make it way out here, so that's what I mean by a vertical compression, is because it takes the number and then times it cuts it in half or a third or a fourth, so it becomes really, really a fat graph with the vertical compression. Okay, so let's look at the next two numbers. So we are looking again at our formula of f of x, And we now know what A does. A is going to make it fat, skinny, and it's going to flip it upside down if it happens to be negative. Okay. What does H do? So we have to think about, what does H do? H is inside the parenthesis by the X, so it actually affects the X. So it's going to move your graph horizontally. So it moves it to the left or to the right. And what's crazy about the left and right is it's actually the opposite of what you would think. Notice we start with a negative. Okay, so if it's X minus 2, it actually is going to move it in the positive direction. You would think it moves it in the negative, but it doesn't, and vice versa. So let's write that down of what H does. So H moves graph to the left and right. And so we're moving it, that's called a horizontal translation. So horizontal, remember, is up sideways, right, left to right. And when we call it a translation, it's just sliding it to the left or sliding it to the right. So the fancy name would be horizontal translation. Oops. Okay, so there's our horizontal translation. And then think about this as it's the opposite of what you think. However you want to put that in your notes to remember, okay, if it's a minus, I'm actually going to the right. If it's positive, I go to the left, which is totally backward of what we would think, okay? So let's look at, let's look at what K does, and we'll write that down, and then I'll just show examples with both because it'll be easier that way, because I'm pushing my time on this. Okay, so K, let's look at K2. K is going to move up and down. So it's going to move graph up and down. So whatever number it is, if it's positive, it moves it up. If it's negative, it moves it down. So it does the numbers normal, whereas the other one is a little bit backward. And they actually call this a vertical translation. So it's our fancy word, is a vertical, because you're moving it up and down. Translation, you're just sliding it. All right, so with the knowledge of what H and K do, let's look at what it looks like when we have an example. So this is my second example here. What if I have f of x? I am going to keep a as just a 1, so I actually am just going to leave it off. So it would look like this. What if I have x minus 3 squared plus 2? So what have I done to the parent graph? Well, we first look at the A, which I purposely didn't include this time. It's a positive 1. So we didn't make it fatter or skinnier. It's a regular vertical and horizontal stretch. So we didn't change the shape of it. But what we did do is we moved it to the left or the right. So you have to think about that. If I have a minus 3, which way am I moving? Okay, so normally the left is the negative direction, but on this one, if I have a minus, it actually moves it to the right 3. So this number here is going to move you to the right 3. And then this number here is going to move you, it's a positive 2, it's going to move you up 2. Okay, so I'm going to take that regular graph and I'm going to move it to the right 3, and I'm going to move it up 2. And I could show that. I'm going to show that with the graph with the X and Y charts, but I want you to know that you actually don't need a chart. You could think about the regular graph and just shift it, and that's the beauty of understanding the translations, is you don't necessarily have to do a chart. But I'm going to do a chart so you can see why it does what it does. Of course, I probably won't have enough room, but that's okay. I'll try to write small. So our formula, it says x minus 3 squared plus 2. Let's put in the number 0 because that's always pretty. So we would have 0 minus 3 squared plus 2. Okay, so think of 0 minus 3. That's going to give you negative 3. Negative 3 squared is a positive 9. 9 plus 2 is 11. Okay, I put in 0, I got out 11. 0 minus negative 2. Okay, then I'm going to put in the number 1. Okay, so 1 minus 3 squared plus 2. So 1 minus 3 is going to give me a negative 2. Negative 2 squared is a 4. 4 plus 2 is 6. So I'm actually going to graph this as we go because you gotta be able to see the whole U, which will bring me to the idea of the vertex in just a second. So if I'm at 0, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's where I'm at on my first one. And the next one's at 1, 6. 1, 2, 3, 4, 5, 6, 1, 6. So we can see that our graph is starting to go down kind of here. So I definitely want more numbers in the positive direction. So let's try like 3 because I want it to go a little faster. So if I have 3 minus 3 squared plus 2, well, 3 minus 3 is 0. 0 squared is 0. 0 plus 2 is 2. So 3, 2. 1, 2, 3, 1, 2. Here's our 3, 2. And then we need to keep going till we start to see the other side of our U over here. So maybe we want to put in 4 or 5. Let's try 4. So we would then have 4 minus 3 squared plus 2. So 4 minus 3 is going to give us 1. 1 squared is 1. 1 plus 2 gets me to 3. Right? 1 squared, 1. Yep. Okay, so over here at 4, we're up at 1, 2, 3. Now can you start to see the U going back up? Okay, so I'm going to graph what I can kind of see here. Once you see the U's back up, it kind of is going to look like this. So this is called the vertex. That's just our turning point, and I want to make sure that you see the vertex. So we always think of the parent graph starting here, and our parent graph on this one is going to look like this. Here's our 1, 1, 2, 4. Okay, so this is our parent graph. Can you see that to move from this 0, 0 on our parent graph here to this vertex here, can you see that we moved to the right 3 and up 2? That's the idea of these translations. It takes your vertex and it moves it. Okay, so from 0, 0, it's going to move it to the right 3, up 2, and then the same shape should be formed as a traditional graph. So you should be able to look at a graph and know that and match it basically by those translations. Also note that your vertex is HK. Okay, so the vertex is going to be H, comma, K. That's the point where it turns here. So if you look, H it always starts with the negative in it. So we have a negative 3 here. So we would write it down as a positive 3. So you're always the opposite sign of what you see for the H on the vertex, and then the same as the second number. So does our vertex at 3, 2? Yep. Okay. And then you could look at another graph. I'm just going to write it. It's going to look kind of ugly down here, but that's okay. So if I just want to look at this, all right, let's do negative 2, x, let's do plus 1, minus 2. So I tried to do all the opposites of what we did on the first one. So if this is our graph, let's think about what we have done. What's the negative 2 do? The negative is going to reflect it over the x-axis, so that's going to flip it upside down. The 2 is then going to make it skinnier. So we're flipping it upside down, we're making it skinnier. Then what are we doing for the left and right? It's a positive 1, so we're going to move it to the left 1, and then the negative 2 will move it down 2. Okay, so what would be the vertex of this one? The vertex is basically your translations to the left, right, up, and down. And so it would be the opposite of what you see, which is -1, and then exactly what you see over here. So this is our vertex. And what I like to do is find the vertex first, and then when you make your chart, the first number that you want to use would be a number right above this number here and a number right below it. That way you have your starting point on your vertex and you have a number to the right or to the left and to the right. So if I was going to graph this, I would want to use the numbers 0 and maybe -2. Okay, so numbers by the vertex. So this is kind of the idea of what all the translations do. I'm going to open this up to questions from you. I think Jason might be the only one that showed up, but maybe, nope, and your sister. So both of you, you are welcome to turn on. Do you have any questions over this?